Assalamu alaikum. We know when an object is burned, it emits out radiation. The radiation emitted out by the burning object is nothing but electromagnetic radiation. And the color of this radiation depends on the temperature of the source. Suppose the object is hot, then it will emit out a red light, and it will start emitting out a reddish orange light when its temperature is increased further. And when it is very hot, in such case it will start emitting out white light. So this clearly shows that the color emitted out by an object depends on its temperature. Suppose I make a ray of white light to fall on a glass prism. Then this ray of light splits into its constant color, and on the other side we'll get 7 different colors. This can be captured on the screen. Okay, the first one violet, indigo, blue, green, yellow, orange, and red. These are the 7 different colors obtained when a ray of light is about to fall on the prism. Now this process of splitting of light into its constant color is known as dispersion, and the pattern which is obtained here is referred as spectrum. It is called as spectrum. This is how spectrum can be easily obtained. So what is a spectrum? From this we understand that spectrum is nothing but a pattern in which spectral lines are arranged or orderly arranged based on their wavelength or frequency. So this pattern in which the spectral lines are arranged based on their wavelength or frequency is referred as spectrum. Now here the plural form of spectrum is nothing but spectra. No, remember this. The plural form of spectrum is spectra. The spectra is broadly classified into 2 as emission spectra and absorption spectra. So we broadly classify spectra into 2. First one is emission spectra. The second one is absorption spectra. In turn, these 2 are classified into 3. Now that we'll discuss one by one. First, now before going ahead, let's tell what is emission spectra. Emission spectra. When light from a source is made to fall on a glass prism, there is nothing but a glass prism, then the light undergoes dispersion. As a result, it splits into its constituent colors. This way, the pattern that you obtain is nothing but the emission spectra. Clear? So here it is classified into three as continuous emission spectrum, line emission spectrum, and band emission spectrum. We'll discuss about these things one by one. First, we'll discuss continuous emission spectrum, which otherwise known as continuous spectrum. So, we need to write the word emission here. Now, this can be simply referred as continuous spectrum. Okay. Now, how it is obtained? Let me tell you. Now, suppose light from incandescent solid or a liquid is passed through a prism, then we get a continuous emission spectrum. Okay. This continuous emission spectrum, as the name denote, consists of all wavelengths ranging from violet to red. Okay, it comprises of all colors of light and placed one after the another in a continuous manner. Hence, it is named as continuous emission spectrum. Fine. What is the example of continuous emission spectrum? A spectrum obtained from incandescent bulb is an example of continuous emission spectrum. Example: spectrum obtained from incandescent bulb. What is this? Incandescent bulb. Incandescent bulb is nothing but a filament bulb. No, this is a filament bulb. Filament bulb is referred as incandescent bulb. Okay, that's all about the continuous emission spectrum. Now I'll discuss about the second type of emission spectrum. Nothing but line emission spectrum, which is otherwise named as line spectrum. Line spectrum, or it is also named as line spectrum. Line spectrum. Yeah, and how it appear? Now, as the name denote, now this spectrum consists of certain lines of a particular wavelength. Anyhow, what is the source of this line spectrum? When light obtained from hot gas is passed through a glass prism, we obtain line emission spectrum. Light from hot gas. Light from hot gas gives out a line emission spectrum. Remember this. And here, it now if you look at this line spectrum, it consists of a large number of spectral lines. So each represents a particular wavelength or frequency. So these sharp lines present in this spectrum, it represents a particular wavelength or a frequency. Understand? Now, the spectrum obtained from hydrogen or a helium gas in a discharge tube can be taken as the example of a line emission spectrum. Remember this. Now we'll go ahead. This is about a third type of emission spectra. What is this? It is nothing but band emission spectrum. Band emission spectrum, or in other words, it is referred as band spectrum. Band spectrum. So as the name denotes, in case of a band spectrum, it consists of large number of spectral lines closely arranged. Now, here the space between the spectral lines are too small that they appear as if they are in the form of a band. Okay, so this kind of spectrum is referred as band emission spectrum or a band spectrum. I hope I understood. And how do we get this? This kind of spectrum is obtained from excited molecules. When light from excited molecules are allowed to pass through a prism, we get a band emission spectrum. In the similar way, as I told you here, in case of line emission spectrum, now we get light from hot gas. This can be obtained from excited atoms. So, line spectrum gives the characteristics of a given element. Okay, and the similar way, band emission spectrum gives the characteristics of a molecule as it is obtained from the excited molecules. What is the source here? Source is excited molecules. So it gives the characteristics of a given molecule. Fine. And how it appears? As I told you, now it consists of a large number of spectral lines closely arranged together to appear like a band. Understand? So that's all about the band emission spectrum. Now we'll discuss about the absorption spectrum. Absorption spectra. Now before that, let me provide some additional information about the band spectrum. Now as I told you, it consists of large number of spectral lines which are present very close to each other. So they appear like a band. And here, this spectrum, this band spectrum, have sharp edge at one end. Now as we go towards the another end, it fades out. It has got the sharp end at one sharp edge at one end. As we go away, it just fades out. Okay, it appears something like this. And here these bands are separated by dark space. And what is the source of this kind of band spectrum? I told you, light obtained from excited molecules give out a band spectrum. Apart from that, ammonia gas taken in discharge tube is a source of band spectrum. Clear? So now let me tell you about absorption spectra. To get the emission spectra, we make a light from a source to fall on the prism directly. But here, in case of absorption spectra, suppose if we have a source of light, this is a bulb which emits out the light in all directions. When a ray of light from this source is passed through some substance, some absorbing substance. First, this substance will absorb the light falling on it. Then whatever gets dispersed here, no, the dispersed light is allowed to fall on a glass prism, or as a prism. Then again, this light undergoes a dispersion and it gives us a spectra called as absorption spectra. It is again classified into three, no, in a similar way. First one is a continuous absorption spectrum. See what I will say? I have replaced the word emission with absorption. So you get the first type of absorption spectra. How do we obtain this? If you allow white light to pass through a blue glass plate, then on the other side we get a blue light. What does this glass plate do? This glass plate absorbs all colors present in the white light and allows only blue light to pass through it. Clear? So this is an example of a continuous absorption spectrum. In a similar way, if you allow white light to fall on a green glass plate, then it will absorb all kind of colors present in that light and it will allow only green to come out of it. No? Again, it is an example of continuous absorption spectrum. Now, in our day-to-day life, we see different materials having various colors. If we take the example of leaves, leaves appear green in color. What is the reason why it appears green? If you ask this question to a biologist, then he may say that the leaves consist of a chlorophyll. That's why they appear green. But if you ask this question to a physicist, then he may say that the leaf absorbs all color which falls on it and emits out only green light. That's why it appears green. Got it? So this is all about the continuous absorption spectrum. Then the second one is line absorption spectrum. Now, when a light from a source is allowed to pass through cold gas. Suppose I have a source, let's see, an incandescent bulb that gives out a light. This light is passed through cold gas. So this cold gas will absorb certain amount of light, and whatever has dispersed here, this is a dispersed light, and it is made to fall on a prism. Then this prism will disperse the incident light, and the spectrum obtained here is referred as line absorption spectrum. For example, if we allow white light from arc lamp to pass through sodium vapor, then the spectrum obtained on the other side will have dark lines in the place of, it will have two dark lines in the place of a yellow region. Now this shows that here sodium vapor has absorbed yellow light. That is why it is absent in the spectrum. Okay. and in the place of that we obtain dark lines. So it is an example of a line absorption spectrum. And here, when we talk about absorption spectrum, this absorption spectrum provides us information about the substance which has absorbed the light. Okay, whereas in case of emission spectrum, it provides information about the source which has emitted out the light. But here, we don't get the information about the source of light, but we get information about the object or substance which has absorbed that light. Clear? Now third one is nothing but band absorption spectrum. Band absorption spectrum. Let's see what is this band absorption spectrum. When the white light from an arc lamp is allowed to pass through a diluted solution of chlorophyll or blood, we obtain a band absorption spectrum. Here, dark bands are seen with a continuous bright background. Okay. Now, band absorption spectrum is also obtained when white light from arc lamp is allowed to pass through iodine vapor. Okay. So, when I say we obtain a spectrum when light is passed through certain substance. Now, after dispersion from that particular substance, we need to pass it through a prism. Only then we will get a spectrum. Otherwise, we will not get a spectrum. Remember this. Okay. So that's all about spectrum and its types. I hope the video is useful. If you have any kind of doubt relevant to the topic, can you put a question in the comment section? Thanks for watching.